Hello friends, good afternoon. In the last class, we studied about the refraction through the prism. We know that prism is a optical medium which is bonded by the two refracting surface and one is a base. So when the refraction is takes place due to the prism, in the last class we derived the expression for the refractive index of a prism. That is n is equal to sine a plus d divided by 2 all divided by sine a by 2, where a is the angle of prism, and we know that the angle of prism is the angle which is find out in between the two refracting surface is known as the angle of prism, and the angle of prism for the equilateral triangle is a 60 degree. And we also study about the angle of prism for a thin prism. So thin prism is that where the angle of a prism is a very small, and we derive the expression for the angle of prism for the thin prism, that is a d is equal to a into n minus 1, where d is known as a deviation, and deviation is nothing but it is a difference in between the incident ray and the emergent ray. The angle which is find out in between the incident ray and the emergent ray, that angle is known as the angle of a deviation. So in this type, we derive the expression for the deviation due to the thin prism, as well as we derive the expression for the deviation due to the prism. So here in this class, we study about the dispersion by the prism. So we know that the prism is used to find out the different colors, or to find out the several colors. Then we know that there are two types of a light. One light is known as a composite light, another one light is known as a monochromatic light. Monochromatic light is a that which consists of a single color or which consists of a single wavelength. And the composite light is a that which consists of a several colors, and when it is incident on the other medium, it is split up into the number of colors. Because the velocity of a light in air is the same, and because of this reason, the white light is means the composite light is observed in a one single color. But this composite light is incident on the other medium, it is split up into the number of colors depending upon their velocity and depending upon their wavelength. Let's see how the dispersion is takes place due to the prism. Prism is used to find out the spectrum, and we know that spectrum is a that spectrum is a that a colors arranged on the screen. When the number of colors are arranged on the screen separately is known as a spectrum. Spectrum is a that when the number of colors are arranged separately is known as a spectrum. There are two types of a spectrum. One is a pure spectrum and another one is known as a impure spectrum. There are two types of a spectrum. Spectrum is a that spectrum. Spectrum is a that when the composite light is a split up into the number of colors, and those colors are arranged depending upon their velocity. Spectrum is a that when the composite light is a consist of a seven colors. Means for the ultraviolet rays are consist of a seven colors, and those seven colors are in the form of a red to violet, red, blue, indigo, green. In this type yellow, these are the seven colors. When this composite light is propagate in the air medium, we know what this is a single color. But when it is an incident on the other medium, it is a split up into the several colors. Means white color is a consist of a seven colors. When those seven colors are arranged separately on the screen, is known as a spectrum. So in this type, if the colors are separated from each other, from the first one is a red and last one is a violet. So depending upon this, when this composite light is split up into the number of colors, that is known as a spectrum. Then there are two types of a spectrum. One is known as a pure spectrum, and the second one is known as a impure spectrum. Impure spectrum. Pure spectrum is a that in which All the colors are arranged separately. All the colors are arranged separately. Means red separate, orange separate, yellow separate, green separate. Means there is a distance is a find out in between the two colors, that is known as a pure spectrum. Or that is a form, means in this we find out the distance in between, or there is an angle which is find out in between the two colors, that is known as a pure spectrum. For example, the colors those are find out due to the prism, that is known as a pure spectrum. Impure spectrum is a that in which all the colors are overlap to each other. All the colors are overlap to each other. Means, for example, there is a red. Second one is a yellow. Again, third one is a green. In this type, both the colors are separate, are overlap to each other. That is known as an impure spectrum. When the composite light is incident on the other medium, there are separate colors are find out. If all the colors are separated, those are arranged depending upon their velocities. Those are known as a spectrum. Spectrums are of two types. One is known as a pure spectrum. In the pure spectrum, all the colors are arranged separately after refraction. And impure spectrum is that in which after refraction the colors are overlap to each other. So when those are for the example for this is a rainbow. When we observe the rainbow after the rain in the sky, we have got the spectrum. And in the spectrum, the colors are overlap to each other. So that is the example for the impure spectrum. Then here, how the dispersion is takes place due to the prism. How the refraction is takes place due to the prism. Then we study about the refraction through the prism. So the use of a prism. The use of a prism is to find out the spectrum. The use of a prism is to find out the spectrum. So here, the prism is that when a composite light is an incident on the prism, it is a refracted. When it is a refracted, due to the changing medium, it is split up into the several colors. So here, how the refraction is a takes place due to the prism. Consider a prism. In the prism, if we consider the prism, in the prism, there are the two refracting sides are there, and the one side is a base A, B, C, where BC is the base, and AB and AC are the refracting surface. So where A is the angle of prism, when the composite light is incident on this, suppose a composite light is a that which consists of a number of colors. Suppose this is a composite light which is an incident on the first refracting surface. So this is a air medium, this is a denser medium. So the ray of light is propagated from rarer medium to the denser medium. So when the ray of light is propagated from rarer medium to the denser medium, it bends towards the normal. So draw a normal line at the point of incidence. Draw a normal line at the point of incidence. Then here, this ray of a light PQ is refracted due to the first surface AB. When the ray of light is incident on the first surface, it is refracted. And we know that this PQ with the ray of light is a composite light. Composite light means, for example, if we consider the white light. So when the white light is incident on the first surface, it is refracted. When it is refracted, it is split up into the number of colors. It is split up into the number of colors. That process is known as a dispersion. That process is known as a dispersion. Dispersion is defined as dispersion. So dispersion is that. Dispersion is that when the composite light split up into the number of colors. In the composite light split up into number of colors number of colors is known as a dispersion. Dispersion. So here, simply, the splitting of light, the splitting of composite light into the number of colors is known as a dispersion. So this is a composite light. When it is entering into the prism, it is split up into the number of colors depending upon their velocity. So suppose this is the first one ray is there are 7 colors are this composite light consists of 7 colors. Out of the 7 colors, if we consider the minimum and the maximum color, that is suppose the first one is there is a refraction and it is a immersion from this. The first color which is a deviated, that is known as a red, and that is a last one color is a violet, and the middle color is a yellow. So here, when the composite light consists of 7 colors. So this composite light is incident on the first surface. It is split up into the number of colors. So when it is split up into the number of colors, that process is known as a dispersion. So when it is split up into the number of colors and it again come outside, that is immersion. So this process is known as a dispersion. And when the ray of light, a composite ray of light is split up into the number of colors, it is split up depending upon their velocity. Depending upon their velocity and depending upon their wavelength. So we know that the relation between the velocity and the wavelength is inversely proportional. That is V is equal to C divided by lambda. V is equal to F divided by lambda. The relation between wavelength and velocity is inversely proportional. And we know that wavelength of a red color is large. Wavelength of a red color is large, means the velocity of a red color is less. Remember this point, velocity is inversely proportional to the wavelength. Means when the wavelength is large, its velocity is less. And red color has a large wavelength. Red color, large wavelength, and a less velocity. And violet color, less wavelength and a large velocity. So in this type, there is a red color is less deviated and the violet color is more deviated. So here, if the prism is not there, means the ray of light is propagated in the straight line direction. If the prism is not there, the ray of light is propagated in the straight line. So this is known as an incident ray. So in this type of, when the composite light is incident on the prism, that prism is a split up that composite light into the number of colors, and that process is known as a dispersion. So when the dispersion takes place, and this dispersion is find out depending upon their wavelength. So when this dispersion or the cause of a dispersion is that this dispersion takes place because of the medium is changes. When the medium it changes, in the other medium, the velocity of each color is different. So depending upon their velocity and depending upon the wavelength, all the colors are separated from each other. In the air medium, velocity of each color is the same, so those are moved with the same distance as well as the same velocity. But when those are entered in the other medium, those are split up into the number of colors, and the splitting takes place depending upon their velocity as well as the wavelength. So in this type of, the splitting of a light takes place, means we have got the first one is a red and the last one is a violet. So the deviation is that process of a splitting of a light into the number of colors. That process is known as a dispersion. This here, what is meant by the deviation? Or what is the meaning of a deviation due to the prism? Next part is Distortion is the splitting of a composite light into the number of colors depending upon their wavelength. That process is known as a dispersion. Then here, what is the meaning of a angular dispersion? What is the meaning of a angular dispersion? Angular dispersion. Angular dispersion. Angular dispersion is denoted by the letter theta. Angular dispersion is defined as it is the difference in between. It is a difference in between the angles of the change in the deviation of the two angles. That is the maximum deviation and the minimum deviation. Or it is angular dispersion is defined as it is the difference between 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 the deviation of the two colors. Deviation of a two colors. Deviation of a two colors. That is known as the angular dispersion. So angular dispersion is a difference in between the deviation of a two colors. If we consider the first color and the last color, that time to find out the angular deviation, angular dispersion in between the red color and violet color. Suppose the deviation is denoted by the letter delta. Then here the deviation of a red color is the angle which is found out in between the incident ray and the emergent ray is known as the angle of a deviation. So this angle is known as the deviation of a red color. Deviation of a red color. And the angle which is found out in between the violet color and the incident ray is known as the deviation of a violet color. So here, deviation of a violet color is a more because the wavelength of a violet color is a less. And the deviation of a red color is a less, and the deviation that of wavelength of a red color is a large, means the velocity of a red color is a less and the velocity of a violet color is a large. So in the straight, remember these things, that is the velocity, wavelength. Then to find out the angular dispersion. Angular dispersion is the difference in between the angular deviation in between the two colors. Therefore, theta is equal to, if the deviation of a violet color, in the last class, we derived the expression deviation due to the thin prism. Use that formula. So, deviation due to the thin prism is equal to A into n minus 1. In last class, we derived this expression, that deviation due to the thin prism, where A is the angle of prism, n is the refractive index. Then find out the deviation due to the violet color as well as deviation due to the red color. Then deviation due to the violet color, dV is equal to A into NV minus 1. That is the refractive index for the violet color. Then this is equation number 1. Then find out the deviation due to the red color. dr is equal to A into nr minus 1. Suppose this is equation number 2. Then find out the angular dispersion, angular deviation. Angular dispersion or angular deviation, that is the theta is equal to difference in between the angle of a two colors. That is the first deviation is a violet, dV minus dr, because deviation of a violet color is a more as compared to the deviation of a red color. Therefore, write down the deviation for the violet color is A into NV minus 1 minus A into NR minus 1. So take a common or substitute A into NV minus A minus A into NR minus minus plus A get cancelled. Therefore, A into NV minus A into NR. NR means the refractive index for the red color, refractive index for the violet color. A take common, A is the angle of the prism and A is the NV minus NR. So this is the angular dispersion. This formula is important for the numericals. So the angular dispersion is equal to theta is equal to A into NV minus NR. So this is known as the angular dispersion. Then here angular dispersion is defined as it is a difference between the deviation of the two colors or the difference in between the deviation of the two color is known as the angular deviation. Then to find out the angular deviation, we consider a prism, and when the composite light is incident on the one side of the prism, it is a refracted or it is a split up into the number of colors depending upon the wavelength. Means red color has a large wavelength as compared to the violet, and the middle color is a kind of yellow. That time, the deviation due to the violet color is a large as compared to the deviation due to the red color. Therefore, angular deviation theta is equal to dV minus dr, where dV is equal to a into nv minus 1 and dr is equal to a into nr minus 1. Therefore, this is equal to a into nv minus 1 minus a into nr minus 1. Simplify this bracket. When we simplify this bracket, a into nv minus a into nr minus minus plus a get cancelled, a into nv minus a into nr. Therefore, theta is equal to a into nv minus nr. So, in this type, this is known as the angular dispersion. Then find out the dispersion power. See here, angular dispersion is a depends upon the angle of prism as well as the refractive index for the violet as well as the refractive index for the red color, as well as it is a depend upon the refractive index of the medium and depends upon the refractive index of a surrounding medium. So in this type, we derive the expression for the angular dispersion. This here, dispersive power. Dispersive power. It is denoted by the letter omega. So dispersive power is defined as it is the ability of the prism. It is the ability of the prism to disperse the ray of light to disperse when the composite ray of light is incident on the prism. That is known as the dispersive power of the prism. This here on which factor the dispersive power of the prism is a depends. So here dispersive power. Dispersive power is defined as it is the ability of the prism to disperse the ray of a light or to deviate the ray of light. That is known as the dispersive power of the prism. Otherwise, dispersive power is also defined as it is the ratio of a angular dispersion to the mean deviation. This here, dispersive power is the ability of the prism to disperse, to split the ray of light, to split the composite ray of light in the number of colors. Otherwise, mathematically we express that dispersive power is defined as is a defined as is a defined as is a defined as it is the ratio of it is the ratio of it is the ratio of angular dispersion angular dispersion angular dispersion to mean deviation to mean deviation. So dispersive power is defined as it is the ratio of a angular dispersion to the mean deviation. That ratio is known as the dispersive power. So dispersive power of the prism is the ability of the prism to disperse the ray of light or to disperse the composite light into the number of colors. Then here, what is the related formula for the dispersive power? Dispersive power is denoted by the letter omega. Therefore, omega is equal to it is the ratio of a angular dispersion. It is the ratio of a angular dispersion to mean deviation. To mean deviation. Angular dispersion. What is the meaning of angular dispersion? Angular dispersion is the difference in between the deviation of a two color. So that is a maximum red color and violet color. That is a dV minus dr divided by mean deviation means it is a dV by dr divided by 2, or the yellow color is considered to be mean deviation. So that is a d minus 1. Deviation d is equal to dV minus dr divided by d. We know that dV is equal to dV is equal to, we can find out the value of dV minus dr, that is A into NV minus NR. NV minus NR. So, deviation D is equal to A into N minus 1. Deviation D is equal to A into N minus 1. N is the mean of the NV plus NR divided by 2, where N is equal to NV plus NR divided by 2. That is the mean. Then D is equal to A into N minus 1. So here, cancel. A get cancelled. Therefore, the angular dispersion is equal to omega is equal to NV minus NR divided by N minus 1. So this formula is related for the angular dispersion, that is a dispersive power of the prism. So dispersive power of the prism is equal to NV, that is the refractive index for the violet, minus refractive index for the red divided by N minus 1. So this is known as the dispersive power of the prism. So in this type, we study about the dispersion due to the prism. Dispersion due to the prism means nothing but when the composite light is incident on the prism, it is split up into the number of colors, that is known as a dispersion. So the arranged colors which are found out on the screen is known as a spectrum. So there are two types of a spectrum. One is known as a pure spectrum and the another one is known as a impure spectrum. When all the refracted colors are arranged separately is known as a pure spectrum. When the colors are overlapped to each other is known as an impure spectrum. So for the pure spectrum, example is a prism. Due to the prism, all the colors are separated from each other. Means by using a spectrograph, the instrument which is found out in the physics lab, we can observe the spectrum of the different colors. And the impure spectrum, the example for the impure spectrum is rainbow. Due to the rainbow, we have got the 7 colors, but all those are overlapped to each other. So in this type, this is the example for the prism. Means in the prism, there is a refraction is that takes place, as well as there is a refraction is takes place. Dispersion as well as a refraction. Dispersion is the splitting of a composite light into the several colors is known as a dispersion. Means due to the prism, we find out the refraction as well as a dispersion. The next part of this chapter, ray optics, is the scattering of a light. Scattering of a light. Scattering of a light is a process. Scattering of a light is a process in which the light undergoes a number of refraction, which is found out in the atmosphere. We know that our Earth atmosphere is made by the different molecules, different dust particles, as well as the oxygen, nitrogen, water molecules. There are so many layers on the Earth's surface. So when the ray of light is incident from the sun to the earth's surface, it undergoes the number of a refraction. It undergoes the number of refraction because when the ray of light is propagated from the sun, it incident on the earth atmosphere, and the earth atmosphere consists of a different layers. Means near to the sky, water molecules are there. Near otherwise, the dust particles are there. So many gas molecules are there, oxygen, nitrogen. So in this type there are different molecules are there. Means when the ray of light is propagated from the sun to the earth's surface, it first incident on the molecules in the atmosphere. It is the first incident on the molecules in the atmosphere. Means our atmosphere is made by the number of molecules. Those molecules are big in size or those molecules are very very small in size. So these light rays are first incident on these molecules. So, according to the law of diffraction, when the ray of light is propagated from one medium to the other medium, it changes its direction. When it changes its direction, means it is a ray of light which is propagated from sun to the earth surface. So, in between the sun and the earth surface, there are so many molecules are there, and these so many molecules that is known as the atmosphere. So first the ray of light is incident on the molecules and this molecule absorb the ray of light or absorb the intensity of a light and it again refracted. So again this refracted light is incident on the other molecule and again there is a refraction is that takes place. Means when the ray of light is incident on the earth surface or it is a passes from the sun to the earth surface, there are so many refractions that takes place. It undergoes the so many refraction and due to the refractions, its intensity of a light is goes on changing. Its intensity of light is goes on changing. Means when the ray of light is incident on the molecule. So this molecule absorbs the sum of the energy of this light. Means it absorbs the sum of the intensity of a light and again it is refracted. Means intensity of a refracted light is less as compared to the intensity of a incident light. As well as it changes its direction. It changes its direction. So there are so many number of refractions that takes place in the atmosphere. So this process is known as a scattering of a light. Means when the ray of light is a passes from the atmosphere, when the ray of light is a propagated in the atmosphere, it undergoes the number of a diffraction and that process is known as a scattering of light. So in the scattering of light, the scattering of a light is a very very important part of a physics as well as due to the scattering of a light, there are important phenomena those are observed in the nature such as the sky look as a blue, otherwise the sunset, sunrise are red color. So these results are find out due to the scattering of light. Then we observe here how the scattering of light is takes place, on which factor the scattering of light is find out, or which law is applicable for the scattering of a light. Then according to the religious, there are two type of a scattering. One is known as a coherent scattering, another one is known as a incoherent scattering. Or one is a coherent scattering which obeys the religious law, or incoherent scattering which does not obey the religious law. So here what is the religious law? This year, when we study about the scattering of light, the first important thing is to study about the religious law. According to the religious, he said that when the ray of light is an incident on the atmosphere, when the ray of light is an incident on the molecules in the atmosphere, that time the ray of light or the intensity of a refracted light. Intensity, this is the incident light. When it is a passes from the molecule, this is known as a refracted light. Then intensity of a refracted light. Intensity of a refracted light is a fourth power of a wavelength. According to the religious, he said that the intensity of a refracted light is fourth power is fourth power of its wavelength. Its wavelength. Intensity of a refracted light is reciprocal. of a fourth power of a wavelength. Means intensity is a directly proportional to the fourth power of a wavelength. Means here the relation between the intensity of a refracted light and the wavelength is inversely proportional. Means wavelength of a light is more, its intensity is less. When the wavelength of a light is less, then the intensity of a refracted light is more. Means depending upon this, the scattering of a light is depends. So according to the religious, he say one law, that is the intensity of a refracted law is inversely proportional to the fourth power of a wavelength. Means there are two laws are there. Means some refraction are obeys the religious law and some refraction does not obey the law of a refraction of a religious. Means those are coherent scattering and another one is incoherent scattering. Coherent scattering is that in which it obeys the law of a refraction or which obeys the religious law. And incoherent scattering is that which does not obey the law of a religious law. Means here, what is the religious law or how the scattering is takes place? When the intensity of a light, intensity means whose brightness. When the ray of light is incident on the molecule, it is refracted. So according to this, when the refraction is takes place, so here this is a composite light. When it is an incident on the molecules on the atmosphere, it is a refracted. When it is a refracted, there is a refracted means again there are seven colors are there. Out of these colors, which color is a more bright? That time, the intensity of a refracted light is a fourth power of its wavelength. Means the first one wavelength is a red, last wavelength is a violet. Violet is a less wavelength. Red has a large wavelength. Red has a large wavelength. Violet has a less wavelength. Then according to the religious criteria, whose color is a bright here, violet is a more scattered as compared to the red. So depending upon this, we study about the some important things in the atmosphere. Scattering of a light is a refraction due to the molecules those are present in the atmosphere. That process is known as the scattering of light. Due to the scattering of light, there are a number of phenomena those are observed in the atmosphere. Suppose if we first study about blue color of the sky. Blue color of the sky. Okay, sky. Blue color of the sky. In daytime, we observe that the color of the sky is a blue. So what is the reason? The color of sky is a blue. So in daytime, we observe the color of the sky is a blue. So the reason for the color of sky is a blue is due to the scattering of light. Scattering of light means the refraction due to the atmosphere. This here why the color of a sky is a blue. So here at the daytime, the sun is on the head. Suppose this is the earth surface and this is the sun. At daytime, the distance in between sun and the earth surface is less. At the daytime, the distance in between the sun and the earth surface is less. So what happened here? From the sun, when the ray of light is incident on the atmosphere, from the sun, the ray of light is incident of the molecules those are present in the atmosphere. So what happened here? This composite light is an incident of the molecules those are present in the atmosphere. That time it is a refracted, and when it is a refracted, it is a split up into the several colors. It is a split up into the number of colors. Means that time what happened here? When it is a split up, those are arranged into the number of colors that is a red to the violet. So according to this red to violet, according to the religious criteria, because the small molecules, dust molecules, those are obeys the religious law. Means the scattering of a violet light is a more, because here it obeys the law of a religious scattering, that is the intensity is a fourth power of a wavelength. So that time when it is a split up into the number of colors, red to violet, there are 7 colors are there. But we observe the color of sky is a blue because the violet color has a less wavelength as compared to the red. Red is scattered, blue is scattered, all the colors are there. But here, the which color has a more scattering, that violet color is a more scattering because it obeys the religious law. So violet color has a more scattered according to the religious law because violet color has a less wavelength. Violet color has a less wavelength and red color has a large wavelength. Means which color is a more scattered here? Violet color. So because of this reason, at the daytime we have got the color of sky is a blue. At daytime we observe the color of sky is a blue, and because of that reflection, the water is also observed in the blue color. So this is the main reason for the color of a sky at the daytime is a blue, because at daytime the distance in between the earth surface and the sun is a less, and when the distance is less and the rays are travel from the sun to the earth atmosphere, there are so many molecules are there, oxygen, nitrogen, those are so many molecules, and when those are incident on this, there is a refraction is that takes place, and all it is a split up into the several colors, but there is a violet color is a more scattered because its wavelength is a less, and because of this reason we have got the blue color of a sky at the daytime. Then the next part, at the sunset and sunrise. At the sunset and sunrise, at the sunset and sunrise color of sky is a red. Is a red. We observe that at the evening, at the morning, the color of sky is a red. This here, what is the reason? Because we know that red color has a large wavelength and its scattering is less, and violet color has a less wavelength and its scattering is a more. But what happened? Because of that reason, at sunset and sunrise, color of sky is a red. So here, at sunset and sunrise time, the distance in between the earth surface and sun is a large. So here, suppose this is the earth surface, and this time sunset and sunrise time, the sun is at one end. Sun is at one end. Means the distance from the sun, to the earth surface is a large. The distance in between the sun to the earth surface is a large. So here what happened here? When the distance in between sun and the earth surface is a large, when the sun rays are travel, when the light rays are travel, those are again incident on the molecules in the atmosphere. Those are again incident on the molecules in the atmosphere. When those are incident on the molecules in the atmosphere, again there is a refraction is a takes place. Again there is a refraction is a takes place, and due to the change in medium, there is a dispersion is also takes place. Dispersion is the splitting of light into the several colors. So it also obeys the law of a religious, that is the intensity is inversely proportional to the fourth power of a wavelength. Means this time also the red color is a less scattered and the blue color is a more scattered. But what happened here? The distance of a earth surface and sun is a large. Means the distance is a large, means the wavelength of a large red color is a large. Wavelength means the ability to cover a distance. Which color has the ability to cover a large distance here? Red color has the ability to cover a large distance. And that violet color has the ability to cover a less distance because the wavelength of a blue color is a less. So here both the colors are scattered. Red color is a less scattered, blue color is a more scattered. But what happened here? The distance in between the earth surface and sun is a large. When the distance is large, means the blue color does not reach the earth surface. If it is a scattered more, but it does not cover a large distance, and because of this reason the red color has a large wavelength and it covers a larger distance, and because of this reason we observe the sunrise and sunset color are red. Next, danger signals are red. We know that the danger signals when on the road, the danger signals are always in the form of a red. Danger signals are in the form of a red because after scattering, red color has the ability to see a large distance and blue color has the ability to see a less distance. So because of this reason, to saw the red color from a large distance, all the danger signals are in the form of a red color. Next one, black color of a sky. Black color of a sky. Black color of a sky. Sometime in the rainy days, we observe the color of a sky is a black. Sometime in rainy days, we observe the color of a sky is a black. So what happened there? In the rainy days, all the atmosphere consists of a big droplet. In rainy days, all the atmosphere consists of a big droplet. Big droplet means when the ray of light is incident on this, the intensity of a incident light and refracted light is a very less. Because they absorb, those are big droplets, they absorb the intensity of the light and the intensity of a refracted light is a very less, and because of this reason, the sometimes in the rainy days we observe the color of sky is a blue and black, and when the color of sky is white, because that time it does not obey the law of a refraction, means the ray of light is an incident and it is a refracted state. When it does not obeys the religious law, that time we have got the color of sky is a white.